Good day and welcome back to our fourth and final installment on vectors. In this video, I'd like to continue our discussion by covering one more example. So we're given the following information. A woman walks, and we do need the direction here, due west on the deck of a ship with a speed of 3 miles per hour. The ship itself is moving north at 22 miles per hour. So with this in mind, let's see if we can find the speed and the direction of the woman, but relative to the water. And in order to answer this question, we need to introduce just a few concepts that we may or may not be familiar with. So the first is that of a resultant force. So let me go ahead and just write this down. So in words, if several forces are acting on an object, the resultant force, i.e. the total resulting force experienced by the object, is the vector sum of those forces. So we see this previously discussed concept. Furthermore, let me go on and just note, and you all can tell me, what is the relationship between speed and velocity? And the relationship is that speed is the magnitude of velocity. So if you're working in one dimension, speed and velocity are the same thing, but once we have multiple dimensions, speed is the length of that velocity vector. So let me draw a very simple picture. So if we consider the boat or ship from this bird's eye perspective, on the deck of the ship, we have this lady. She is walking relative to the ship, we'll say due west, at a speed of 3 miles per hour. So we could represent this as a vector -3, 0. And how I'm coming up with this is -3 is indicating we're going in this negative x direction, and the magnitude of this vector is simply 3. And just to make sure we're all on the same page, let's just go ahead and note that if you find the magnitude of -3, we take the square root of the sum of those components squared. And the square root of 9 gives us that desired speed of 3. Now, furthermore, note that the boat is moving relative to the water, where it's going north at 22 miles per hour. So we could represent this vector as 0, 22 for similar reasons. And in order to find the desired quantity here, the speed and direction of the woman relative to the water, what we need to do is find the velocity vector of the woman relative to the water. Then we can determine that speed and that direction. So in terms of her velocity, it is made up of kind of two quantities. There's how quickly the boat is moving relative to the water, and then we have to add on to that how the woman is moving relative to the water. That is this resultant force. So the velocity of the woman relative to the water is given by the vector -3, 22. And the speed would be the magnitude of that velocity vector, which would be the square root of the sum of the components squared. And note, this is not a nice whole number, so I would actually prefer to leave it in this exact form, opposed to given some decimal approximation that one might get in their calculator. Now to get the direction, let's think about the vector that we have. The vector is described as being -3, 22. So roughly speaking, let's think 3 units away from that positive vertical axis and 22 units up from the origin. So if we could figure out this angle, that would be a perfectly good way of describing the direction. And in terms of just some right triangle trig, because we do have a right triangle, we can say that theta would be the inverse tangent of opposite over adjacent. And if we were to plug this into our calculator, we would get approximately 7.77 degrees. And you don't have to plug that in. This is just one of those scenarios where I think it's maybe nice to have this approximate value, because 7.77 degrees, or approximately 8 degrees, is something we can visualize, whereas a quantity like arctangent of 3 over 22 is certainly a bit more nebulous. So how I would describe this is as follows. I would say that the direction is given as north 7.77 degrees west. And in words, what this would be is 7.77 degrees west of north. And if you prefer to write it out in some various form, that is most definitely okay as well. So this finishes up our discussion on vectors. And as always, I just want to throw out there, if you have questions, do not hesitate to reach out, send me an email, stop by virtual office hours. But otherwise, stay tuned for our next topic, and take care.